Hi everyone, I am Kunal and today we would be doing a question from HC Verma, and it is an interesting question, and there are multiple ways to solve it, and we will look at those multiple ways. Let's look at this question. That there is a cylinder which is released from rest. There is a cylinder which is released from rest from the top of an incline of inclination theta and length L. If the cylinder rolls without slipping, what will be its speed when it reaches the So there is a rolling cylinder. It's going like this. How much speed does it acquire? How much speed does it acquire on down? They have given the angle theta, inclination angle, and the length L of this incline. So one way to do this question is, because you know that why, let's try to study the center of mass of the cylinder, because they are not asking anything about the rotational part, they are only asking about the center of mass part. Now let's try to write out let's imagine that the cylinder is somewhere here in the middle. It is getting a force mg here, and we resolve it into components, so we get an mg sine theta in this direction. So let's try to mg sine theta, and this would be equal to m into acceleration of center of mass. Is it fine? And does it work? Okay. So we get an acceleration of center of mass. In the problem, it's given that the cylinder started from rest, so the velocity is 0. This velocity is to find, and this distance is given. Using kinematics equations, you can get the results. But there is something missing here. Now that is a very interesting part, that when you try to do the question from this approach, you have to take care of the rolling as well. See, if the cylinder, if there was used to be a ball which can't rotate, this would have been perfectly well. It's going like this. But when we say that the cylinder is rotating, then the reason why cylinder is rotating is because of some torque, right? And who is applying that torque? Is the torque being applied due to this mg sine theta? No, the gravities cannot apply the torque because the rotation is happening about the center of mass. So the torque is being applied. The torque is being applied by a friction force in this direction. And external torque is equals to moment of inertia about center of mass into angular acceleration. And external torque is the force into r, if the r is the radius. So this is the ball or cylinder, this is the friction, this is the r, this is the center of rotation. It's basically perpendicular to the plane. So F into r will give me half mr square. Is for cylinder, it is half mr square equal to the ring, and alpha can be written as a by r. So we actually get something out of this, and r this cancels out, so we get a is equals to, we get f is equals to ma by 2. So now there has to be something like ma by 2 as well, but it is acting in the opposite direction. Mg sine theta minus ma by 2. And now when we cancel, sorry, there is a small m, this is a small m, this mass, there is only one object, so there is nothing to be confused about. So when we take here half, 3 by 2, so there will be 2 by 3 here. So this is where you have to be really cautious of when you are drawing such diagrams, that you have to understand that the rolling motion is happening because of friction, so you must include the friction force in the FBD diagram. So V is equals to u square plus 2as. I hope you are clever enough to find the speed. I won't do that. Now there is another approach, which is a very simpler approach, which does not require much of the understanding of the forces and all, and that is And that's the power of that approach. That the alternate approach is the conservation of energy approach. And this is why the conservation of energy is a very interesting principle, and it's very useful principle. It can just solve the problems, and it can help us to analyze the motion, because we all know that the energy is always conserved. Now this was the diagram. This was the cylinder, reached here, started with zero velocity. Wait. Started with zero velocity, reached here. Now when we say that initially the cylinder was at this height, so because of gravity, it must have some gravitational potential energy. How much it is? Mg, and this length. And we know if this is given theta, and this direction is this angle, this, 1 second, and this is theta, so that would be mgl sine theta, right? Mgl sine theta. And when it will reach at the bottom, it will have kinetic energy, but it will have a translational kinetic energy, and it will have a rotational kinetic energy, which will be half I omega square. And we know that if this is v and this is omega, so we have a relation between omega is v by r. So omega is v by r, right? So now I don't want to do it, but this conservation of energy means gravitational potential energy is equals to translational kinetic energy plus rotational kinetic energy. Know where the energy is spent otherwise, right? And 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 then now we can just put it the formula mgl sine theta y must l into half mv square plus half I v square by r square. See, you know mass, you know g, you know all this, right? You know everything, and you have to just find v. You don't know v, sorry, you don't know v. You don't know v. So you don't know this v and this v, you can take it together, and v can be find out. M can be cancelled because I will also contain M, so you can find out v. So yeah, it makes sense. This makes sense. And it would come out to be something under root 6gl sine theta. Something like that. Oh sorry, 6 by 3 or something. 4 by 3, sorry. It would be 4 by 3 gl sine theta. Now is it making sense dimensionally? So this check is important. Check, because you can mostly, this is the advantage that physics offers, that you can check your answer. Dimensional check हो रहा है क्या? So acceleration meter per second square multiplied by meter square plus second square under root meter per second. Yeah, theta is dimension here. And does it make sure that if you increase the length, the speed increases? Yeah, obviously. And if theta increases, speed increases? Yes, obviously. So yeah, this looks correct. Thank you.